Y'all, I had a really busy weekend, so I didn't have an opportunity to shoot a video. But here we are, and I'm going to finish up my little series on blood with hormones and endocrinology. And essentially, the primary communication system within the blood is what's called the endocrine system. And that essentially means things that are secreted inside. You have an exocrine system as well, and a juxtacrine system, and all of these other secretion methods to communicate in the body. But the endocrine system is a huge number of glands throughout the body that secrete various chemicals into the blood that get transported everywhere to send a particular message. So these chemicals sometimes are called hormones, and sometimes they land on the outside of a cell and then cause something to happen inside the cell. Sometimes they pass right through the membrane and cause something to happen in the cell. So these are the big, wide-ranging pamphlets of the body. Anytime that you need to tell the whole body some message about what's happening outside or inside of your body, the endocrine system is what kicks in and does this. So I'm going to use a couple examples of the hormone cycle for a couple different kidney hormones. So first I want to talk about a hormone called erythropoietin, and it's usually abbreviated EPO, and that's what I'll probably be referring to it mostly as. But EPO tells your bone marrow to produce new red blood cells. So as I talked about in I think I talked about it in toxins and blood filtration, when red blood cells die, they go to the liver and get dismantled, and then the kidneys start sensing that there is not enough red blood cells. So they send a little message up to the adrenal gland, and the adrenal gland starts shooting out EPO until there's enough red blood cells. So the EPO goes to the bone marrow starts differentiating into red blood cells. So differentiation is the process where a pluripotent or totipotent stem cell chooses which genes to activate and puts whatever that cell is, or turns into a specific type of cell. And I'll talk lots about differentiation when we get to the fascial system in a couple of weeks. But anyway, so the pluripotent stem cells turn into red blood cells and get introduced into the bloodstream. The kidney senses higher levels of blood cells and then tells the adrenal gland to stop secreting this hormone, and it gets metabolized through the bone marrow and whatnot. So these cycles happen pretty constantly as we go through our day. We have some amount of red blood cells, and it dips a little, and it raises a little, and dips, so on and so forth. Another one that I think is more fascinating because you feel the effects of it more, or it's more personally relevant, I suppose. I guess one personally relevant thing about erythropoietin is there are athletes who do blood doping, right? So it's not it is a external chemical that you add to your system, but essentially synthetic or, curated EPO that you swallow, and then it gets into your blood system, and your blood cell or red blood cell levels rise. And then because there's no system regulating anymore, and you had this huge jump, you have a really high number of red blood cells for 60 days or so. They start to drop off a little bit as other red blood cells die, and then once all of those die in a really short span, because they have a pretty limited time in the blood, then you totally crash and become anemic because you haven't been replacing red blood cells throughout that 60-day period. So the other one I want to talk about is one everyone's familiar with, and that's adrenaline. So it's another kidney hormone or another adrenal hormone, and it is responsible for fear and the fight or flight mechanism, and we all know its effects, whether it's stress from school or a horror movie or a haunted house or, some paranoia or irrational fear you've experienced for whatever reason. We've all felt that adrenaline sensation. And so that has a cycle of the brain has some idea that there is something threatening, right? I've got a teacher who describes it as the lion-shaped hole. Our brains were developed to protect us from a imminent and dangerous threat, like a predator. And because we've eliminated all predators in our life, our brain is still looking for that predator. So there's a lion-shaped hole in our psychology that we're always looking for this imminent life-threatening thing. So we attach that to work or school or whatever. And then we get an adrenal response whenever that thing pops up. But unlike a predator, we can't run away from work or school. So the adrenal response isn't actually beneficial to our health. We end up just clogged up with all of this adrenaline hormone. The only way to get rid of the adrenaline hormone is first get your body to stop creating it. So you have to either deal with the problem or deal with your response to that problem. And then you have to actually do the fight or flight mechanism that your body wants to with that. So you need to have a good cardio workout. I always recommend burpees for people who are stressed in school or whatever, but going for a run, getting any other kind of get your body moving, muscles and blood, is a great way to help with adrenal stress and then also adrenal fatigue when that burns out. So we see in our world, because there are lots of people with lion-shaped holes and few people with lions, we have this system that keeps secreting this hormone until our body is totally fried and unable to secrete the hormone or do anything with the hormone. And then we end up in this state called adrenal fatigue. And it doesn't really work all that well to be a human in adrenal fatigue. So those are a couple examples of hormones and their systemic effect on the body, right? So EPO is a little bit more specific, more localized. You have one specific trigger and it goes to one specific outcome and it happens in this little cycle, right? Whereas the adrenaline is more, there are more factors involved, right? You've got the psychological response that triggers it, and then you've got the blood and muscles and your digestive system changes how it's working. It shuts down to a certain degree while you're in adrenal stress. So it has these wide-ranging effects in your whole body. But all hormones affect the whole body, right? EPO goes from one gland to every bone in your body at the same rate because blood goes everywhere, right? So that's the beauty of the hormonal and endocrine control of the body, is that it announces the same thing to everything in your body at once. And there's just some hormones that affect certain cells, and there's some hormones that affect all cells. I think that's a quick, easy description. There is so much to learn in endocrinology, both from the Western perspective, looking at molecules and hormones and trying to divide which goes where and how the little cascades go, and then from the Eastern perspective of just trying to associate elements and organs with emotions, with systems, with the general health of the human. And there's lots to talk about in that. Maybe I'll do another video on ancient Chinese predictions of hormones, because there's plenty to talk about with liver hormones and EPO, incidentally. But yeah, that's my quick overview of endocrinology. I hope you enjoy and watch my other videos on blood or any of my other videos you like. Like and subscribe, and I'll see you guys soon.